Welcome. As stakeholders in the secondary wireless market, you know that our industry moves fast. Success here depends on more than just the devices themselves. It depends on the trust and clarity we establish with our partners and our customers. Today, we'll review a tool designed to strengthen that trust. The CTIA Wireless Device Grading Scales Criteria and Definitions, version 5.0. It's likely your organization already has internal grading systems that work well for your specific operations. However, when devices move between different companies, these varying scales can often lead to confusion or mismatched expectations in the market. The CTIA grading standard provides a universal sheet of music for the entire industry. It's a common language that ensures everyone, from B2B wholesalers to the end consumer, is on the same page. For the technician, it removes the guesswork. You no longer have to wonder if a scratch is too big. You have the tools and the protocol to know for sure. For the business, it creates a predictable supply chain. When everyone grades the same way, a pallet of devices stays consistent from the warehouse to the storefront. For the consumer, it builds confidence. They know exactly what they are buying, which reduces returns and keeps them coming back. Our goal for this session is to show how the standard can help your business maintain consistency, reduce friction, and keep the wireless market moving forward efficiently. Let's get started. It is important to recognize that this document was not created in a vacuum. This industry standard represents a truly collaborative effort across the entire wireless device secondary market. The CTIA grading standard was developed with extensive input from a diverse group of stakeholders. As we look at the contributors on screen, you'll see the breadth of expertise involved in this process, such as original equipment manufacturers, OEMs, network carriers, resellers and retailers, parts distributors, repair facilities, technical solution providers, insurance and warranty providers, reverse logistics and supply chain experts. By incorporating the perspectives of these various sectors, the standard has achieved global adoption. The table of contents is broken down into four main sections. Section 1, the introduction. Section 2, grading scales. Section 3, the grading scale matrix. And Section 4, a simplified cosmetic grading classification specifically for wearables, along with two appendices. Moving into the core of the document. Section 1 provides the high-level foundation for these grading standards. Purpose. The primary goal is to establish a common lexicon and unified process for the grading of wireless devices. By creating this shared language, we eliminate the guesswork. To maintain clarity, any variations from these defined criteria must be clearly disclosed to customers. In terms of scope, the guidelines are specifically limited to the device types identified in the document's definitions, such as smartphones, feature phones, tablets, and wearables. This document is intentionally aligned with recognized global benchmarks, including NIST guidelines for mobile security and the R2v3 standard for electronics reuse and recycling. By grounding our terminology and processes in these international frameworks, Section 1 ensures that when we talk about a grade, a device, or a refurbished unit, we are all operating on the same professional wavelength. Welcome to the heart of the standard. Section 2, Grading Scales. This is where we establish the absolute technical framework that removes subjective opinion and replaces it with objective, measurable data. The grading scale schema is designed to clearly identify a device's condition across these 5 core categories. Cosmetic grades. Devices are assigned a letter grade from A like new to E heavy damage, or N not graded, based on the severity of physical wear. Functional classification, a numerical scale 1 to 9 that identifies the operational health of the device. Lock status. Separate numerical scales categorize the status of customer locks, enterprise locks, and operator locks. RF test grading scale evaluates the device's radio frequency functionality and network connectivity. Kit configuration identifies what accessories or packaging are included with the device. Now let's dive deeper into these categories, starting first with the cosmetic grade. The standard establishes 6 distinct cosmetic grades to categorize the physical condition of wireless devices. These are Grade A, like new condition. Devices in this grade have minimal scratches and blemishes. The external liquid damage indicator, LDI, must not be triggered. Grade B, light wear and tear. This grade allows for more scratches and blemishes than Grade A, but there must be no lens cracks on any surface. Similar to Grade A, the external LDI must not be triggered. Grade C, more aggressive wear and tear. This classification allows for some cracks on specific surfaces, such as the camera or rear lenses. However, it does not allow cracks on the display cover lens. The externally viewable LDI must still not be triggered. Grade D, heavy cosmetic damage with cover lens cracks. This grade is used for devices with excessive damage on multiple surfaces, including cracks on the cover lens. The internal display structure must remain intact. Devices may be missing small parts, such as side keys or front camera, and the LDI may be triggered, provided there is no corrosion. Grade E, heavy cosmetic damage with internal structure damage. This represents the most severe damage level, including damage to the internal display structure. The LDI may be triggered with or without signs of corrosion. Grade N, not graded. This is applied when a device has not been inspected for cosmetic defects or if its condition is unknown. Because different parts of a device impact the user experience differently. For instance, a scratch on the screen is far more distracting than a scratch on the battery door. The standard ensures defects are weighted appropriately by location. It accomplishes this by establishing a precise geographical map of the wireless device, dividing it into 4 distinct surface areas, AA, A, B, and C. We will now take a closer look at the specific surface areas, beginning with AA. This surface is defined as the most critical area for visual inspection, encompassing the main displays and all camera lenses. This designation applies to all screens and cameras on a device. These diagrams illustrate the AA surface across diverse form factors, including standard smartphones, tablets, wearables like smartwatches, and the complex dual-screen layouts of foldable devices. The foldable device exception. For foldable devices, internal displays with manufacturer-applied replaceable screen protectors may be reclassified as a B surface if any dents or scratches do not penetrate the actual internal display, as it can be replaced without device disassembly. The AA surface is inspected for defects such as scratches, dots, cracks, fingerprints under the glass, foreign material, dust, pressure spots, discoloration or shadows, air bubbles, and lifted lenses. The AA surface refers to the front areas of a device that are not part of the main display or camera lenses. On a typical smartphone or tablet, the A surface encompasses the front housing and periphery surrounding the display, while on wearables, it specifically targets the bezel. For foldables, this category is expanded to include both the front and camera bezels, ensuring that the structural framing of these complex devices is inspected with a consistent set of cosmetic standards. The A surface is inspected for defects such as scratches and dots, cracks, dents, warping, gaps, discoloration, stains, and lifted lenses. The B surface comprises the sides and the back of a device's housing. It covers a wide range of external components, such as SIM tray, side keys and buttons, USB port area, audio mesh grill, and microphone holes. For foldables, B also includes the hinge mechanism and its cover. These diagrams illustrate the B surface across diverse form factors, including standard smartphones, tablets, wearables like smartwatches, and foldable devices. In addition to the standard defects found on the A surface, such as scratches, dots, cracks, and dents, the B surface is inspected for burrs, dusted mesh, along with hinge and screen protector issues for foldables. The C surface refers to internal areas, connection points, and components typically found under covers or doors, also labels, logos, and screws. The C surface is inspected for defects, such as connector issues, damaged SIM tray, and label integrity. The viewing and inspection protocol establishes a standardized environment and method to ensure consistent device grading across the industry. Inspection process, environment, and tools. Lighting. Inspection must be performed under lighting typically found in a factory environment. This is technically described as a cool, white, fluorescent light source with a recommended minimum of 500 lumens. Distance. The inspector should hold the device at arm's length with a slight bend in the elbow, approximately 18 inches from their face. Vision. The inspector must have 20/20 vision, naturally or corrected. Magnification. Use of magnification is strictly limited to verifying the size of a defect, rather than identifying it. Viewing angle. The device should be viewed straight on. Rotating the unit to find a defect is generally not required for basic identification, though tilting is used for specific surfaces. Scan time. Each surface area is scanned once without dwelling on any single spot. 4 seconds are allotted for scanning each standard surface area. 6 seconds are allotted specifically for the AA surface, main display, and camera lenses. The 45-degree tilt. To accurately identify cracks or scratches on the AA surface, the inspector should tilt the device back 45 degrees. With the inspection environment established, we move to the fundamentals of a defect. Here, we define how to categorize physical damage into 4 distinct defect levels. These levels are determined by 2 factors: precise measurements and the tactile fingernail test. The Level 1 defect. Level 1 defects are considered minor. These are tiny scratches or dots that are barely visible and can only be seen from certain angles. To qualify as Level 1, the defect must be no longer than 0.5 millimeters and no wider than 0.05 millimeters. You cannot feel a Level 1 defect with your fingernail. The Level 2 defect. Level 2 defects are clearly visible from a standard inspection distance of 18 inches, regardless of the viewing angle. These defects can be up to 1.5 millimeters long and 0.5 millimeters wide. Crucially, while they are visible, you still cannot feel them when running a fingernail over the surface. The Level 3 defect. Level 3 is where the fingernail test becomes the primary measurement. These are deeper scratches, up to 2.0 millimeters long. When you run your fingernail across a Level 3 defect, you can physically feel the groove, but your nail does not catch or stop inside the scratch. The Level 4 defect. Level 4 represents significant damage. This includes any scratch longer than 2.0 millimeters or wider than 0.5 millimeters. If you perform the fingernail test and your nail catches or completely stops in the defect, it is automatically classified as Level 4. Additionally, any cluster of smaller scratches in a single area is treated as a Level 4 defect. To ensure accuracy, inspectors always use a standardized measurement gauge and a 0.25 millimeter gauge tool. These levels are the building blocks used to decide if it's a grade A, B, or C. Defining the defects is only half the process. The final step is mapping those defects to a specific grade. To do this, we utilize Table 2.7:1, the cosmetic grading scale. This table acts as a cross-reference guide, matching the surface area, where the damage is, with the defect level, how bad the damage is. Think of it as a grid. The surfaces AA, A, B, and C are on the top, and the grades are across the left. When reading the table, look for the intersection of the surface you are inspecting and the grade you want to achieve. Each cell tells you the maximum allowable defect level for that specific area. If a single defect exceeds the level listed in that cell, the device automatically drops to a lower grade. Grade A is reserved for devices with minimal signs of use. On the AA surface, that's your main display and camera lens, 0 defects are allowed. It must be pristine. On the A surface, which is the front housing or bezel, you are allowed a maximum of 3 Level 1 defect. This is a tiny scratch you can't even feel. For the B surface, the back and the sides, Grade A allows for a maximum of 5 Level 1 defects. Grade B allows for more visible wear, but still maintains a good standard for the screen. On the AA surface, the display, Grade B allows several level 1 and 2 defects. This means the screen must still look good, but scratches are noticeable to the naked eye. On the A surface, the bezel, you can have many level 1, 2, and 3 defects, and a few for level 4. The wear is noticeable to the naked eye. On the B surface, back and sides, the standard relaxes further. Acceptable defects types by surface. While we use precise tools to measure the length and width of scratches, some defects are more subjective. These are appearance-based flaws that are difficult to measure with a gauge, but have a big impact on how a device looks. To handle this, the right side of the table specifically lists what types of these subjective defects are acceptable, depending on which surface they are. We have now completed our comprehensive look at Section 2, Grading Scales. This section has established the technical bedrock of the CTIA standard, moving device evaluation from subjective guesswork to a verifiable, repeatable science. From the pristine like new requirements of Grade A to the heavy damage classifications of Grade E, every tier is governed by precise rules. We've detailed the geographical surface areas of a device, AA, A, B, and C, ensuring that a defect on the screen is weighted appropriately compared to a mark on the housing. The grading scale matrix serves as the framework for applying these factors to arrive at a final cosmetic classification. Classifying functional failures. In the world of device grading, not every failure is treated the same way. Table 2.8-1, titled General Descriptions of Common Failures, provides the industry standard for separating issues into two categories, minor and major. This distinction is vital because it determines whether a device can be resold as is, or if it must be sent for repair or salvage. First, let's look at minor failures. These are issues that might be annoying or look imperfect, but they don't stop the phone from being a phone. Display imperfections. These include cases where there are fewer than 3 missing pixels or visible burn-in images localized to the top status bar or menu areas. Because the screen stays fully operational and touch-responsive despite these marks, the standard classifies them as visible imperfections rather than total functional failures. Other minor failures. We also categorize certain hardware issues as minor if the device remains fundamentally operational. This includes failures of secondary features like the camera flash, proximity and light sensors, the headset jack, or the vibration motor. While these certainly impacts the device's convenience and usefulness, the standard recognizes that the primary functions of the smartphone remains. Next, we have major failures. These are the deal breakers. A major failure is a defect that compromises the core functionality of the device. Display. When it comes to major display failures, we look for issues that significantly hinder usability. This includes more than 3 missing pixels, screen burn-in that has reached the center viewing area, or the presence of discolored lines and spots. More critical issues, like a total failure of the touch digitizer or a backlight that is too dim to read, are also classified as major. In almost every one of these scenarios, the damage is severe enough that a complete display replacement is required. Other major failures. Major failures also encompass the core components that make a smartphone smart. If the rear or front cameras, speakers, or microphones fail, the device loses its primary communication and capture capabilities. Similarly, hardware issues like unresponsive side keys, a dead battery, or a charging port that no longer accepts power are considered critical. Finally, any loss of essential connectivity, specifically Wi-Fi, Bluetooth, or GPS, is classified as a major failure, as these defects significantly hinder the core features and utility of the device. Table 2.8-3 establishes a numerical functional classification system. This system allows sellers to universally identify a device's operational health on a scale of 1 to 9. The classification ranges from fully functional to non-functional, with specific tiers for devices that require minor repairs or parts replacement. Level 1, fully functional. The device is assured to meet all original OEM specifications. Levels 2 to 4, minor functional issues. These levels generally cover devices that are functional but may have minor hardware failures. Levels 5 to 8, Major functional issues. These classifications are reserved for devices with significant failures in core components, such as the display, motherboard, or battery. Level 9 non-functional. The device is completely inoperable or is intended for parts reclamation/recycling. A device's performance is only as good as its power source. Table 2.8-4 establishes a numerical battery health threshold system on a scale of 1 to 3, providing specific criteria to determine if a battery is acceptable for resale or if it requires immediate replacement. We measure this primarily through maximum capacity relative to when the battery was new. When a device enters the secondary market, its physical condition is only half the story. To ensure a device can actually be used by its next owner, we use tables 2.9-1 through 2.9-3. These tables provide a standardized numerical classification for 3 types of digital barriers: customer locks, enterprise locks, and operator locks. First, we look at table 2.9-1, which deals with the customer lock. This refers to personal security measures like Apple's Find My, Google's Factory Reset Protection, or standard pins and patterns. A classification of unlocked means all personal accounts have been successfully removed, making the device ready for a new user. If a device is classified as locked, it is considered a major functional impediment, as the next owner will be blocked from accessing the home screen. Next, Table 2.9-2 covers enterprise or MDM locks. These are locks placed by a corporation or school to manage their fleet of devices. Even if a phone is factory reset, an enterprise lock can automatically reactivate, restricting features or tracking the device. The standard requires these to be identified and cleared. A device still enrolled in a management program is flagged here, as it cannot be fully owned by a retail consumer until the organization releases it. Finally, Table 2.9-3 defines the operator or carrier lock. This identifies whether the device is SIM-locked to a specific provider, like AT&T or Verizon, or if it is universal and can accept any SIM card. While a carrier lock doesn't make a phone broken, it significantly impacts its market value. Identifying this status ensures the buyer knows exactly which networks the device is compatible with. A smartphone's value is ultimately tied to its ability to communicate. Table 2.9-4 defines the basic RF functionality check, which is the industry standard for testing a device's radio frequency capabilities. This table ensures that the internal antennas and wireless chips for cellular are all performing as intended. The scale identifies whether basic RF functionality check was performed. If it was conducted, a pass/fail result is determined using 3 primary verification mechanisms. Network detection, confirming the device identifies and registers with a cellular carrier. Live call, establishing a real-time voice connection to verify end-to-end signal transmission. RF shielded box, testing the device within a controlled interference-free environment using specialized diagnostic equipment to measure precise signal output and sensitivity. Table 2.10-1 provides a numerical scale to define the kit configuration of a device. This allows sellers to clearly identify what accessories or packaging are included with the device as it enters the secondary market. The scale ranges from 1 through 6, representing different levels of completeness for the retail kit. Up until now, we have looked at cosmetic defects, functional failures, battery health, lock status, and basic RF functionally checked separately. Table 3.1-1 is where it all comes together. This table is the cosmetic and functional classification grading scale matrix. It is the final cross-reference tool that takes everything we know about a device, from its screen scratches to its battery health, and assigns it a final grade. AA, Premier Grade. This is the highest possible grade. To qualify, a device must be in cosmetic grade A, like new, a functional classification of 1 fully functional, greater than 80% battery health, unlocked and RF tested with specialized testing equipment. By utilizing this matrix, the industry can take complex data points, such as the depth of a scratch on the AA surface and the functional health of the battery, and distill them into a single, recognizable grade. We've now walked through the entire architecture of the CTIA wireless device grading standard, from the precision of the cosmetic grading scales to the critical thresholds of battery health and the strict requirements of functionality. By establishing this rigorous, data-driven framework, the industry has successfully eliminated the guesswork from the secondary market. We no longer rely on a technician's best guess or a subjective opinion of what looks good. Instead, every evaluation, from a microscopic screen scratch to the internal capacity of a battery, is backed by clear, measurable criteria. The ultimate goal of these tables and matrices is transparency. When we follow these guidelines, we ensure that whether a device is labeled grade A or grade C, its physical and functional story is told with absolute consistency. In a world where billions of devices are finding a second life, this standard is the foundation of trust. It ensures that functional means functional, unlocked means unlocked, and quality is a guarantee, not just a label.